To graph a rational function, you find the asymptotes and the intercepts. Then you plot a few points and sketch in the graph. Once you get the swing of things, rational functions are actually fairly simple to graph. Let's work through a few examples.
First, we're going to learn how to find intercepts. To find the x-intercept, for the equation y equals 2x plus 5 over x minus 1, to find the x-intercept, you assume that the numerator is equal to 0. So, 2x plus 5 equals 0. 2x equals negative 5. Divide by 2 on both sides. You get x equals negative 5 over 2, which is the same as negative 2.5. So our x-intercept will be at negative 2.50.
Wait, why are you deleting it?
Let's find the y-intercept now. To find the y-intercept, plug in 0 for the x's, and you'll find that the y-intercept is 0, negative 5. So in this graph, our intercept is at negative 2.50 and 0, negative 5.
Next, you will be learning about vertical and horizontal asymptotes. The problem that I will be teaching is how to find the vertical asymptote. The equation above is the equation that we will be using for this problem. This is a rational function. To find the vertical asymptotes, you set the denominator equal to 0 and solve for x. In order to solve for x in this equation, you must first factor x squared minus 5x minus 6 is equal to 0. This factor will be x minus 6 quantities in parentheses, then x plus 1 quantity in parentheses is equal to 0. X will be equal to 6 and x will be equal to negative 1 given this equation. X cannot be 6 or negative 1 because if so, the denominator would be 0. And as we all know, the denominator of a fraction could never be 0. The graph should always approach an asymptote but never cross it. And you will have asymptotes at here, negative 1, and here at negative 6. And these lines go on forever. How do I find the horizontal asymptote? Well, first, when dealing with horizontal asymptotes, you want to look at the degree and the coefficients associated with x. So for the equation I've written in black above, if the degree of the numerator is smaller than the degree of the denominator, y is equal to 0. So in the following equation that I've written in red, if the degree of the numerator is the same as the denominator, then look for the coefficient of the largest degree of the numerator and the denominator. That coefficient in this case will be 2 over 3. This will give you the horizontal asymptote for this graph. The third type of horizontal asymptote you might encounter is if the degree of the numerator is greater than that of the degree of the denominator, in which case there is no asymptote. For the red equation, the horizontal asymptote will be right in between 0 and 1 at 2/3. And as for the blue equation, there would be no asymptotes, which is why there's no blue in this graph.
So next, we're going to learn how to find the sign charts in a graph. Let's take an example of the equation y equals 2x plus 5 over x minus 1. To find the sign charts, you need to find the zeros of the numerator and the zeros of the denominator. In the equation above, the zeros of the numerator will be at negative 5 halves, and the zero for the denominator will be at 1. To find the sign charts for the numerator, you would plug in a big positive number, and you would find that to the right of negative 5 halves, we would have positives, and you would plug in a small negative number that's less than negative 2.5. So let's say we plug in negative 10, we would find that to the left we would have negatives. In the denominator, you would plug in a big positive number that's greater than 1. So let's say you plug in 10, you would find that to the right we would have positives, and to the left, when we plug in a number less than 1, let's say negative 10, we would have negatives. And that's how you find the sign charts.
Holes in the graph of a rational function are generally produced by factors that are common to both the numerator and the denominator. In the function f of x equals x plus 2 over x squared minus 4, it may not look like that there is a factor that is common to both the numerator and the denominator. First, you must factor out the denominator to make sure that they do not share any factors. Since they do share the common factor of x plus 2, this factor will produce a hole. The factor x minus 2 produces a vertical asymptote. To see the hole on the graph, you set x plus 2 equal to 0 and solve to find the x-coordinate of the hole. The coordinate will be x equals negative 2. To find the y-coordinate of the hole, you must reduce the function and then plug in the x-coordinate into the new function. Once you solve, y will equal negative 1/4. And as we can see in the graph, when we go to negative 2 on the x axis and then go to the graph right about here, we can see that y equals negative 4. However, when you graph the hole on a graph, there should be a circle that represents it, and the circle should not be filled in all the way. Depending on the window of your graph on the calculator, you may not be able to see the hole, but it is important to remember that it is there.
We're going to be solving the rational function y equals 1 over x squared minus 4. The first thing that you do with this equation is to factor it. So you would factor and make it y equals 1 over x plus 2 parentheses and x minus 2. Next, we will be finding the intercepts. To find the x-intercept in this equation, you plug in 0 for x, and the intercept will be at 0, negative 1/4. So in this graph, our intercept is at this point.
Next, I will be instructing you about how to find the horizontal asymptotes and the vertical asymptotes of the exact same equation that you guys found the intercept for previously. So the first thing you want to do when you're trying to find the horizontal asymptote, which I like to abbreviate as HA, is to look at the degrees in the numerator and look at the degrees in the denominator. As you can see, the numerator is raised to the degree of 1. So, and the denominator is raised to the second degree. Given this scenario, we learned previously that the horizontal asymptote is 0. The vertical asymptote is found when you set the denominator equal to 0. The next thing that you want to do is to simply add 4 to both sides of this equation. That will give you x squared is equal to 4. Then you simply take the square root of both sides in order to get x alone, and once you solve for the square root of 4, you'll get 2. This gives you your vertical asymptote. On the graph, I will represent the horizontal asymptote with the color blue and the vertical asymptote with the color red. The horizontal asymptote at 0 will go along the x-axis, and the vertical asymptote at 2 will cross the x-axis at, guess what, the number 2.
So next, we're going to be doing sign charts. So the sign chart for the new is all positives. For the denominator, we have our zeros at 2 and negative 2. To the right of 2, we're going to have positive numbers. In between 2 and negative 2, it's going to be negative. And to the left of negative 2, we're going to have positives.
Because there were no common factors in the numerator and the denominator, there are no holes in this graph. Now we can start to graph the function. First, you will want to draw in the asymptotes at x equals negative 2, and at x equals 2. Now we will draw in the y-intercept, and the coordinate for this was 0, negative 1/4. So that's about right there. The other asymptote will be at y equals 0. Now we can complete the graph. We know that the graph must approach both of the asymptotes. So for this section here, we're going to approach x equals negative 2, and we're going to approach x equals 2. For the next part, our graph will continue to approach y equals 0. And we will have the same thing on the other side.